Welcome to mathworksheet.org. Today I want to show you how to solve using right triangle trigonometry. So what we're going to do is we're going to look into solving problems with the triangle. And a couple things we need to know about this triangle is it's going to be a right triangle. So I want to look at the properties of a right triangle. A right triangle we can determine by one of the angles is going to be right, which we call 90 degrees. And we like to denote that 90-degree angle by this little box. The side length across from the 90-degree angle is what we call the hypotenuse. That is going to be the longest leg of your triangle. The other two sides are what we call the legs of your triangle, and they also have special names. Now, the way that we get their names sometimes is going to fluctuate depending on the triangle. And it's also going to depend on where our theta is, and theta is just a way for us to describe an angle, kind of like another variable. So if my angle here is theta, my adjacent side is going to be the side length that connects my angle theta and my right angle. The opposite side is going to be the side length of the triangle that is opposite from my theta. So once I know all lengths of a right triangle, what I'm going to do is I'm going to be able to take a problem, and by using the side lengths, I'm going to use three different functions to help us solve the problems. The three functions are our sine function, our cosine function, and our tangent function. Now we use these functions for our angle theta, and what they're going to do is use the ratio of the side lengths for the triangle. One way that you can always remember these ratios, if you're always thinking, sine is going to be the ratio of what two sides, remember it's going to be opposite over hypotenuse. So a lot of times we say SOHCAHTOA, which says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's go and take a look at this problem and see how we can use sine, cosine, or tangent to solve it. So I look at the problem and it looks very similar to this triangle. However, it is flipped around. I do notice that it's a right triangle. They both share my 90-degree angle. Then I look at and I notice the angle across the 90 degrees is going to be 20. So therefore I know that 20 is my hypotenuse. I look at my angle here is going to be theta. So 34 degrees is my theta. The side length is directly across from there, so therefore it's going to be my opposite side. Now we could think about which function we're going to want to evaluate for, but when you look at these three functions, we can only use the function that has the side lengths that we're given. So we're given the opposite, the hypotenuse, and theta. So I look at my three trig functions and I notice the only one that I can use my opposite and the hypotenuse with an theta as my angle is going to be the sine function. So what I'm going to do is I'm going to write sine of theta equals the opposite over the hypotenuse. And those are going to be the lengths of your triangle. So now I know what my theta is. In my triangle, theta is 34 degrees. My opposite side, I do not know, so that's going to be x, over my hypotenuse, which is 20. Now, I'm either going to want to use a table or a scientific calculator to evaluate for sine of 34. When I plug that in, or check my table, I notice that sine of 34, when rounding it, equals 0.56. So I'll have 0.56 is equal to x over 20. Now, what we simply have to do is solve for our x. So to get my x by itself, what I need to do is undo dividing by 20. So to undo division by 20, I need to multiply by 20 on both sides. So therefore, the 20 out here cancel out, and what I'm left with, 20 times 0.56 is going to be 11.2. Therefore, now what I've just determined is that my opposite side length for this triangle is equal to 11.2. So that's how you answer this problem using right triangle trigonometry and my trig functions. Make sure you guys go and check out mathworksheet.org for more problems. Thank you.